All right, happy day 8. Let's go. Okay. Oh my goodness. Oh my gosh. Okay. Well, this is interesting. You barely reach the safety of the cave. Right. So we are looking at 4-digit 7-segment displays, and they are rendered by turning on or off 7 segments. Right. Maybe this isn't our input. Thank goodness. Okay. So to render a 1, only segment C and F would be turned on. Right. The problem is that the signals have been mixed up. The Okay. So we're still producing output, but the wires are connected to segments randomly. And the connections are different for each of the 4-digit displays. So we have four. Okay. Oh, this is complicated. So we have 4-digit displays. For each 4-digit display, the segments have been connected to wires randomly. But all the digits within a display are the same. So we know that B and G are turned on, but that doesn't mean that segments B and G are turned on. Um, that must be a 1, so it means that segments C and F are meant to be on. Oh my goodness. So we're going to watch the changing signals, make a note of all 10 unique signal patterns. Oh, this is the note. Okay. So we are writing down the output values, and we're supposed to use these to figure out which um, which pattern. Let's see. So this is the output value. Oh, this is so complicated. Oh my god. Okay. We don't know what the connections are. So all of the connections are the same, but we don't know what they are. And 7 is the only digit that uses 3, right? So we can like limit it down. This is gonna be so hard. Oh my god. Um, 4 is the only digit that uses 4 segments. Right. Okay. Using this information, we should be able to work out which combination of signal wires corresponds to each of the 10 digits. Then we decode the 4-digit output value, which I'll use 5 segments, right? Oh. Um, okay, well, this is. So the first part of the problem doesn't seem like it's even that hard, but I feel like we're going to be asked to do the hard problem for the second part. So I guess we can start out by parsing a display. Gosh. Okay. Yes. So let's okay, well we don't want that. Let's just figure out how to parse all this. So let's have a data structure for just like one of these chunks. So display um what is this even called? It's like a signal combination. So type signal combination. And I think this is just going to be a septuple of bools. And we'll just say it's true when that signal is on and false when that signal is off. So it's going to be bool, let's see, 7 pull of bools. Okay, is that 7? I just didn't want to write them. Copilot figured it out. Thanks. Um, okay. So let's figure out how to parse a um one of these. So parse signal combination. We'll take a string and return a signal combination. Parse signal combination signal is going to be yeah, I'm kind of okay with that. Starting with a list, map. Is there a contains? Let's see. I mean, I'm sure there is. A, let's see, a bool. Elem, right. So, elem signal. And then we'll just map a B, C, D, E, F, G. B, C, D, E, F, G. That's 7. And close that. Okay, does that work? Let's see. Yes, parse signal combination. So let's do like ABC. True, 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 false, 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 false. That seems fine. Combination. A, G, B, C, F, D. Sure. Okay. Yes. Let's see. So maybe this would be easier to do as a list. I just feel like the sevenness of it, I want to be able to make that explicit in my typing. Maybe that's dumb. Let's just truck on with this. So count wires on. Show me how to do that. Yeah. There's no better way to write that? No, there is. Some map. Isn't there a better way to write that? Isn't there like a if function? Let's see. B, C, B, B, A. What would it take? No, it needs to take a bool, and then it returns a B. Bool. Oh, okay. So is that right? Bool 1, 0. We need that from something. Huh. Imagine that. Let me just make sure. Bool 1, 0. It true. Oh. Bool 1, 0. True. False. Okay. Yes, but these are the wrong way around. Okay, so let's we always do that. R. Okay. Let's try like parsing one of these again, and then count wires on it. Gives us 6. That's right. Okay, so that's good. I don't think we're gonna be doing this very quickly today, but that's okay. So for our input, we're going to have a bunch of signal wires. So let's see. So in it will be the signal combination. Another list. It's a list of those. So let's break out that middle type. Type entry signal combination. This will be a list of entries. And then parse will be map parse entry. Come on, help me. Parse entry. Yes. No. And what would this need to return? Split on. String entry. Wait a minute. No. Let left, right, left, right equals split on that input in yes. And this will just be a string map parse signal combination words, right? Oh, this should return a signal combination. A list of signal combinations. Yeah, there we go. Yeah, that's fine. And I kind of want to do this like inline, where parse, let's make that small. Parse combinations. Okay. Okay. So, we want to get, so so we also are going to need to parse entry A. It looks like we're only interested in the output values. And we can just smash them all together. Get input A, transform input A. We'll take an input, and yes, it will just be a list of combinations. Cat map. Yeah. It's just the second ones. Yeah, that was actually, that worked very nicely. Copilot helped a lot. And now we just need to length filter it needs to be either, let's see, so 7 has 3, 4 has 4, 1 has 2, and 8 has all 7. Count wires on. Yeah. Yeah. So let's just test this. Is that even right? Do we have anything near a right answer? Let's see. No. Non-exhaustive patterns. Uh-oh. Oh, these shouldn't be wrapped. This is not Python. Let's see. Language plain. Be gone. Oh my goodness. So, I don't know why it's like that. I think it should be like this. So let's try that again. 26. That was right. So, so let's go get our puzzle input, and maybe, just maybe, it's kind of fun. This is not Python either. Plain text. Okay. So there's our full puzzle input. Yes. Yes. Run. 479. Okay. So that was the easy part, I think. We're gonna find out what else we have to do. Yep, I knew it. So we need to determine the remaining digits. Oh. So we're gonna get the result for each line. Okay. So what we need is what do we need? We need something, so it's going to be some map get um, get output digit. Yes. Get output digit. Get output number. And then we need to define this, which takes an entry and returns an int. Right. And this is going to be, so I think we need some kind of number left, right. So we're going to need let get mapping, solve mapping of the left side in some it's not gonna be the sum, it's gonna need to be the decimalize apply mapping. So what is this going to be? Mapping, and this is going to be a mapping. And the mapping will be a list of 7 numbers, a 7-uple of ints, where each number corresponds to the corresponds to the correct output position, like where that wire actually goes. Yes. Oh no. Okay, so a type mapping is a tuple of 7 ints. Yes. Okay. And we're also going to need, in our like intermediate work in solving mapping, I think we're going to need to have some sort of way to represent like all the possible mappings. Mappings is a tuple of 7 int lists. Type possible mappings and not this. Yes. This is gonna be bad. I'm starting to regret that I didn't use the yeah, how are we even gonna do this with a tuple? God, I'm really wishing. I'm gonna keep plowing on even though I feel like it's a bad idea. And let's see. So this is going to take a mapping map. So that's wrong now. That should, yes. This we can do. Decimalize get digit map to digit. To digit is going to, oops. What is this going to return? I think this is going to just return another signal combination. And to digit is going to take a signal combination and return an int. Okay, and to digit, I think we can just do by like writing out all the possibilities explicitly. So have we been told which segment is which? Yes, up here. So 0 true, true, 3, C, false, true, 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 equals 0. 7 segment display mapping. That's not right. 2-digit, false, false, true, A, B, C, D, E, true, false, 1. Okay. Has it started to figure this out yet? True, B is false, C is true, D is true, true, false, true. That one looks good. Can Copilot do it? True, no. True, false. True, true, false, true, true. Good. 4. False, true, 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 false, true, false. 5. Yes, false, no. True, true, false. True. False, true, true. 6. Yes, just C is off. 7. True, false, true, false, false, true, false. I feel like I have to double check this one. A, B, C, D, E, F, G. Yes. And then 8, all on. And 9 is just missing 1. Equals error, invalid signal combination. Okay. What are we missing? What are you mad at? We need to define decimalize and turn a list of digits into a decimal number. Oops. I lost it. And yes, I think that's right. Let's just double check. Decimalize 1, 2, 3, 4, 1234. Perfect. Okay, so let's see if 2-digit, and then let's do a signal combination. A, B, C, E, F, G, 0. A, C, F, A, B. Error. Good. C, A, B, oops. A, B, C, E. Let's see. A, B, C, D, E, F, G. Okay, I think this is okay. This is working. And oh my goodness. Okay. I'm just like putting off the solving part because I don't know how I'm gonna do it. So it might be time to figure that out. A, B, C, D, G, F, B. Oh, this is so complicated. Okay. This one is hard. I think I'm going to take a little break and I might end up putting this off. And I think I'm going to think about it and come back later. Because that's always a good thing to do. Obviously, I'm not going for speed today. So I think I'll probably upload this as the part 1 of day 8. And then you can look forward to another part in which I actually solve part 2, I hope. So I will see you in the second part of this installment of the Admin of Code. Thanks for watching.